This is the solution video to the asummative practice test. This is the same format as your tests that you will have on Friday. Problems will be different, but they will be very similar. I'm going to just work through this and go through each problem, and I will also post just an answer key on the webpage, and I'll also obviously doing a video. So the first step is to find the greatest common factor and the least common multiple. That's what these abbreviations stand for. 36 and 60 using any method. The easiest method to do this problem is the ladder. To do the ladder, I just take 36 and 60, put them next to each other, set up the division ladder, and find a common factor. Any common factor. So the first one that comes to mind for me is 6. Now I do division. I do 36 divided by 6. The result is 6, so I put my answer there. And then I do 60 divided by 6, and I get 10. Since 6 and 10 still have a common factor of 2, I continue my division ladder. 2 goes into both 6 and 2, 6 and 10. So I just do division again. 6 divided by 2 is 3. 10 divided by 2 is 5. Now, since 3 and 5 have only 1 as a common factor, I'm at the bottom of my division ladder, and I can use my work to find the greatest common factor and the least common multiple. To get the greatest common factor, I take all of the numbers on the side and I multiply them. So the greatest common factor would be 6 times 2, which is 12. To get the least common multiple, I take the bottom of the ladder, the very bottom, and I take the number on one side and multiply it by the very top of the ladder on the opposite side. For example, 3 times 60. 3 times 60 is 180. That's the least common multiple. You might be wondering what would happen if you did 5 times 36 instead. 5 times 36, 5 times 6 is 30, carry the 3, 5 times 3 is 15, add 3, you still get 180. So I picked the 3 times 60 because I could do that multiply quicker than the 5 times 36. Problem 2 is find the prime factorization of 72 and write it in exponent form. So basically for that, you need to use a factor tree. That's one of the easiest ways. So 72, you can pick any factor pair of 72, even starting with 2, if that's the only one that you know. 2 times 36 is 72, so I can start with that. Since 2 is prime, I'm going to circle it to remind myself that that's going to be part of my final answer. 36 isn't prime, so I continue the tree. 6 times 6 is 36. Neither of those is prime, so I continue making branches. 6 is 2 times 3. So now, the bottom of every branch is a prime. So the expanded form of the prime factorization would be 2 times 2 times 2 times 3 times 3. But using exponents, as the directions ask you to, since there's 2 multiplied together 3 times, we say that's 2 to the 3rd power times 3 to the 2nd power. We've even talked about, I'm going to write that under the answer blank because it's a little crowded, using a dot for multiplication. That's something that we are starting to do more. But you could also, in this case, use it times because it's not an algebra problem. So it's not confusing. Like the times, you can use the times better. Okay, for number 3, this is a bigger problem. You have to go backwards. Now you have the prime factorization, and you have to write an expanded form. 2 times 2 times 2 times 3 times 3 times 7. That's a big, giant multiplication problem. So 2 times 2 is 4. And 4 times 2 is 8. And 8 times 3 is 24. And 24 times 3, might have to think about it a little bit slower, but you could do 3 times 20, which is 60, and 3 times 4, which is 12, and you'll get 72 when you add those together. And now 72 times 7. You have to work that out. This would be a good place to use that distributive property. 72 times 7. I think that sometimes this distributive property really makes things much simpler. 7 times 7 is 49, so 7 times 70 is 490. 7 times 2 is 14. So my final answer is going to be 490 plus 14. So 504. Okay. Order of operations. Let's zoom in here a little more. So that problem is 60. I'm going to even write it a little bit bigger. I'm just going to copy it, so I'm not sure how well that would show up on the computer screen. Okay, so we go and do parentheses first because that's the first step in order of operations. So now we have 60 divided by 10 times 2 plus 7 times that 2 right there minus 2. Might be easier to read if I move that down a little bit. So I did the parentheses. There are no exponents, so now I do multiplication and division, whichever comes first when I look left to right. So I'm going to do 60 divided by 10, which is 6, times 2 plus the 7 times the 2 minus the 2. So now I keep continuing on. Multiplication still exists, so I have to do that. 12 plus 7 times 2 minus 2. Still have multiplication in the problem. So 12 plus 14, take away 2. 12 plus 14 is 26, take away 2. So my answer is 24. Remember that every time you do an order of operations problem, it should sort of like funnel down when you show your work to get smaller and smaller until you have the final answer. Let's look at the one over here. Again, I'm going to copy it so it's easier to read on the computer. Okay, first step, parentheses. So I'm going to do 24. So I just copied this part of the problem over. When I get to the parentheses, I'm going to work the inside. So I have 9. Inside the parentheses, I have to do the multiply first. Minus 8. I have to continue with the parentheses. That's a 1. So we talked about this in class more today. When there's just one number in the parentheses, right here, when the numbers are next to each other, that means multiply. That was a new concept for people. So I've done the parentheses, now I have to do the exponents. So 24 stays alone. This is 2 to the third power, which is 2 times 2 times 2 plus 3 times 1. We have to figure this out, this exponent out, before we do the division. So that's 8. 2 times 2 times 2, 2 to the third is 8. 24 divided by, so we have to treat that exponent as the higher operation before we do the division. Now, 24 divided by 8 is 3. I'm going to run out of space here, so I'm just going to cross this out and work right below it. It's down a little bit. You can do the same. So 24 divided by 8 is 3 plus 3 times 1. So 3 plus 3 is 6. So we'll just put the answer over here, put a box around it, so you know it belongs with that work. Okay. Next question. It's a mystery number. I have a square number. My digits form an odd sum, and my only prime factor is 3. There's so many ways to do this. You could look at all the square numbers, or as many as you can think of, but that would take a while. You know, like 1's a square number, 4 is 1, the next one's 9. The first 2-digit square number is 16, so you could continue that, but that might take a while. We wouldn't even count these because it says my digits form an odd sum, and you would need 2 digits. So one strategy is to write out the square numbers. The other strategy is to use the last clue and look at what it says. My only prime factor is 3, so the number has to either be 3 or 3 times 3, so that would be 9. That is a square number, but it doesn't have digits to add up, so I can't do part B. So I can try 3 times 3 times 3, so that would be 9 times 3, which is 27. So that is 2 digits, and the digits sum to an odd number, but it's not a square number. So we have to keep going. 3 times 3 times 3 times 3 would be 27 times 3. 27 times 3, using that distributive property for multiplying. 3 times 20 is 60. 3 times 7 is 21. 60 plus 21 is 81. That is a square number. So there is your answer. If that was a hard method for you, I would just continue the list of square numbers. 4 squared is 16, 5 squared is 25, so 4 squared, 5 squared. 6 squared is 36, 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. So you could say, write your square numbers out and then add the digits up. 1 plus 6 equals 7. So that works. But there's no 3 as a factor of 16. 16 doesn't have a 3 as a factor. Neither does 25. Neither does 49. Neither does 64. Neither does 100. So you would look at your factor trees for 81, which 9 times 9, 3 times 3, and that has all the factors are the same. All the prime factors, there's only one, it's 3. But when you look at 36, you have 4 times 9, so it has 3 as some of the prime factors, but it also has prime factors of 2. And part C said the only prime factor is 3, so it can't be 36. It has to be 81. So the answer has to be 81. Let's go to the next page. Distributive property. We worked on this a lot in class today. Write each expression for the area of the rectangle below in expanded form and factored form. Factored form has parentheses. Expanded form does not. So that was where we did 2 methods, where we expanded form, we found the area of each rectangle. So the area of this rectangle is 3 times 4, and the area of this rectangle is 4 times 6. Just erase that and write the 4 first in both of these. So the expanded form is 4 times 3 plus 4 times 6, because together, if you had to find the area, it doesn't actually ask you to find it, but if you had to find the area, it's a good thing to check. It's 12 plus 24. The area of the whole thing should add up to 36. The factor form takes a different approach. It says take that 4 and multiply by 3 plus 6. So the factor form is just 4 times 3 plus 6. And if you wanted to check that one, you'd say 4 times 9, and that works out to be 36. So you got the same thing in both methods, so that should give you confidence that you've done it right. And then when you read a little bit farther, it then does ask you for the area of the rectangle. So the area is 36 square units. Remember, area is always in square units. And some of you like to use the shorthand, 36 with a little unit squared. Both of those are okay. The next problem, we also worked on these in class today. Kind of like a going backwards problem. You have to find the missing dimensions. So what numbers go here, and here, and here? So you have to find those numbers. So you want to find a common factor of 9 and 21. One way to do that is just think of the ladder. We'll do it 2 ways. But 3 goes into 9 3 times, and it goes into 21 7 times. So what that tells you is 3 times 3 gives you when you multiply these, you get 9. So you could put a 3 here and a 3 here. And 3 times 7 gives you 21. So you can put the 7 down here. So the ladder method works nice, but for some people, it's not as easy as just writing a list of factors and finding common factors other than 1. Just because we talked about not using the 1 as a width, because it simplifies the problem too much. So something other than that solution with a 1. So the factors at 21 are 1 and 21 and 3 and 7. So when you look at this, the common factor is 3. So what's common to both would go there. And then the factor pair, those pieces go down here. Because 3 times 3 gives you the 9, 3 times 7 gives you the 21. All right. This next problem is a lot like the quiz problem, but also there's a lot of problems that don't have to do with music and radio stations that are like this. One of the examples we did in our homework was buying hot dogs and buns because they come in different amounts in a packet. You had to figure out how many packets of hot dogs and buns each to buy so you don't have anything left over. So just because this is one type of problem, don't forget to look at some of your ACE problems for other examples. So let's read the problem. 2 radio stations, Alice 105 and Kiss FM, both play the song Roar. They did a lot last year by Katy Perry. I'm going to make this a little smaller. Alice plays this song every 8 minutes, so I'm going to write some work down to keep my thoughts organized. Alice plays the song every 8 minutes, and Kiss plays the song every 20 minutes. Both stations play the song at noon, so when is the next time the stations will play the song at the same time? So just to get the problem in your head, for example, at 12:08, Alice will play the song again, but Kiss won't be playing it until 12:20. So at 12:16, Alice will play the song, but still Kiss hasn't played the song yet. At 12:24, Alice will play the song again, and Kiss has only played it once. So really, we're looking for multiples. We're really looking for the first or the least, which is also the first common multiple. So once you know that, you can continue your list, or you can use the ladder. Okay, so if we continued our list, Kiss would play it in 40 minutes. Alice, we saw, played it 8 minutes later, 16 minutes later, 24 minutes later, 32 minutes later, and 40 minutes later. So that's the first common multiple. Or you could use the ladder, which when you have some numbers, the ladder is quicker. Take out a common factor of 2. 8 divided by 2 is 4. 20 divided by 2 is 10. Take out another common factor. 4 divided by 2 is 2. 10 divided by 2 is 5. Remember, take the bottom of one side and multiply by the top of the other. 2 times 20. 40 minutes later. So at 12 o'clock, 40 minutes later, would be at 12:40. They will both play the song at the same time when it's 12:40. All right, let's look at this problem. Chloe's helping plan a party for her neighbor's daughter. She wants to make party bags for everybody at the party. She has 60 fireballs, those little candies, and 36 tattoos. She also wants to make sure that each party bag has the same number of treats in it. What's the greatest number of people that can come to the party so that each person gets an equal number of fireballs and tattoos? So basically you have to divide equally the fireballs and tattoos. So we have to divide them up, so we're going to use factors. So we're going to use a division ladder to find the greatest common factor. So if I have 60 fireballs and 36 tattoos, I'm going to actually move this up here. So I can put up here 60 is my fireballs, and then 36 is my tattoos. I know that 6 goes into both of these, 10 and 6 times. I know that 2 goes into both of these, 5 and 3 times. So that means my greatest common factor, 12 people can come to the party. And each would get 5 fireballs and 3 tattoos. So 12 people for part A. For part B, I don't even have to do any more work. Right there, they would each get 5 fireballs and 3 tattoos.